Welcome back to Smith Coding and Design. This will be the first tutorial in the series where we go over how to machine a DDC pump top on our Tormach MicroArc 4th axis. So let us go ahead and begin. So our setup is going to be fairly simple. As always, you can grab the vise model with the parametric stock in it, as well as the DDC pump top model from the description below. So make sure you guys go ahead and do that so you can follow along. So with that said, let's go ahead and begin. So the first thing we're going to do is go ahead and drag in our model. Because we have our 4th axis and we can rotate our stock, we're really going to do all of our machining operations in sort of one setup. So normally if I was using, say, 2 vise fixtures, I would make a separate assembly and then drag in both vise fixtures. Because it's all done in sort of one setup here, all I'm going to do is go ahead and drag in the model of the pump top, and then what I'm going to do is go ahead and rotate it 180 degrees. There we go. And I'm going to press enter, and now all I'm going to do is orbit over here to the front face. I'm going to press J for joint, grab the center, and then I'm going to join it to our parametric stock. So if it does this to you, don't worry. All that you need to do is come over here and press flip, and then it will go into the stock just how we want it to. Now what I want to do is I want to be able to do a 2D contour and clean up the outside edges of the part. So I'm going to move the part inside of the material 50 thousandths. So I'm going to go ahead and do that now. All right, that looks good. I'm going to press enter, go back to our home view. And so that is sort of it for getting the part inside of the material. So what we'll do now is we'll go ahead and transition into the cam operation. So I'll go ahead and close this. That way we have a nice full screen here. And so now we'll go to the manufacturing tab, go to our home view. And so now we'll go ahead and we will start with making our setup. All right, so I'm going to come over to setups. I'm going to right click and go to new setup. We now need to tell Fusion 360 where our stock is. So I'm going to click on the stock tab, go under mode and select from solid. I am then going to expand the drop down menu under our models here and select our parametric stock. So now Fusion 360 knows where our material is. From there, I'm going to go back to the setup tab and I'm going to actually select the model, which is our pump top. And then I'm going to select all of the components that make up our fixture. So let's go ahead and select all of those. And the main body of the vise is sort of hiding under this bodies tab. So I'm going to expand it and select. So now we have all of our fixture component selected. What we need to do now is set up our WCS. So I'm just going to go to the front view because this is how my 4th axis is mounted on my machine. It's to the left. So my X-axis should be, arrow should be pointing to the right. My Z-axis should be pointed up and my Y-axis should be pointed forward, in which case it is not right now. So what I want to do is go ahead and go to select Z and X plane. Let me orbit just a little bit so I can do that. And I want my Z plane to be here. We'll go ahead and make sure it's pointing in the right direction. And then for X, I want my X to be along this. So there we go. My X is pointed to the right, my Y is pointed forward, and Z is pointed up. So that's how I want my axes oriented. So what I'm going to do now is go ahead and click on box point, and then I'm going to select the center. So we are now at the center of rotation, which is also the center of our material. So if you want to learn more about how all of that is determined, make sure you watch the videos on wrapping my head around 4th axis machining. So that will go over the probing routines and how to find the center of the A axis through PathPilot. So again, make sure you guys go ahead and do that. So now we have our setup complete. We'll go to post process and give it a name. So I'll call this DDC Pump Top. Just so when we go to generate our G code, we have a recognizable name. All right, so that's good for me. I'm going to go ahead and click OK. And so there you have it. Our setup is done. And so now we'll go ahead and jump into our toolpaths. All right, so the first thing we're going to do is a 2D face. So I'm going to come up here and select a 2D face. I'm going to go into my tool library, and I'm going to be using tool number 8 for me, which is a Gorilla Silverback 3/8 3-flute end mill. So we'll be using this end mill a lot. Again, I don't have a tool changer, so I'm going to try to use one tool for as many operations as I can. If you have a tool changer, that may not be the case. So let's go ahead and select OK. I'm going to be going at 8,000 RPM, and I'm going to go 40 inches a minute. All right, so that gives us 1.6 thou per tooth. That all looks good. So what we'll do now is we'll look at our geometry tab, and you'll see that there's a problem here. If we were to leave the current geometry selected, and this is how we would do it if we were in a traditional vise setup, where we would essentially face the entire top of our stock. Well, if we do that, we would run into our vise and crash our machine. So I'm just going to go ahead and click OK and show that to you guys. So let's go ahead and right click and simulate. And you'll notice here two things. One, we are sort of machining toward the vise when I think it would be preferred to sort of go 90 degrees. Instead of going straight toward the vise, we'd be going across the top face of our part. And the other issue again is, since it thinks we want to machine the entire top of our stock, boom, we crash into our vise, which ruins our day. So we don't want to do that. What we want to do is exit this. We'll go back and fix it. So we'll go to right click, edit, go back to our geometry tab, and we're just going to select the outside contour of the top of our model. So there we go. That's good. The next thing we want to do is go ahead to our passes tab. And again, you notice how we were machining toward the vise when we sort of want to go 90 degrees or across the top of our model. Let's go ahead and make that pass direction 90 degrees. The next thing I'm going to do is change a step over to be 50% the diameter of the tool. So I'm going to go ahead and enter that now. And then what I'm going to do is go ahead and enable multiple depths. So for roughing step down, 40 thousandths is fine. I'm also going to add a finishing step down and go a little slower. I'm going to go 25 inches per minute just to try to get a smooth top surface finish there. So let's go ahead and make this a finishing step down of 20 thousandths at 25 inches per minute. Again, just trying to get a nice surface finish. All right, so that should be good for the most part. So one last thing I'll show you here is, so we solve the pass direction. So if we right click and we simulate, you'll see now if I just drag through the timeline here, we are indeed going across the part and not toward our vise. And we'll just go all the way through one pass. You notice we stop and we do not collide with our vise. Another nice feature with Fusion 360, if there is a collision, it will show up as red down here on your timeline. So just keep that in mind. All right, and so the other thing I want to do, so we'll have to go back in and edit our facing operation, is the tool. If we go to the, let's go to the front view, it's sort of going exactly on the edge of our part. And I want it to come a little to the left just to make sure that we do indeed face the entire top of our part and there isn't, you know, a little bit of material that we didn't face off the top of our part. So all I'm going to do, let me go back to the home view, is go and right click and edit, go back to passes, and I'm just going to add a stock offset of 50 thousandths, click OK, If we simulate again, actually we don't even need to simulate. You can see how we moved 50 thousandths worth of material past the edge of our part. So that way we do indeed make sure that we machined all the way across the top face of our part. So I'm good with that. So that does it for our facing operation. The next thing we're going to move into is a boring operation. So now we're going to go to 2D and we are going to select bore. All right, so I'm going to select my tool. I'm going to go ahead and go to my Tormach library and use the same 3/8 inch 3-flute Gorilla Silverback end mill. We'll go ahead and select OK. I'm going to go at 8,000 RPM and we are going to go nice and slow at 25 inches per minute. That gives us right around 1 thou per tooth. Okay, so everything there looks fine. Again, 8,000 RPM, 25 inches per minute, 1 thou per tooth. Okay, so now what I'm going to do is go into geometry. So here's where things get interesting. What we want to do is go ahead and select what we're going to bore, which is going to be, actually we can't select it yet until we set up our tool orientation. So that's a good thing Fusion 360 is doing here. It's not letting me select that bore. So what I'm going to do is I want to bore this G1/4 hole. So what I'm going to do is go to tool orientation. And so again, what I find helpful is if I go ahead and I orient my fixture and my model the way it would be in my machine when my 4th axis rotates. And so what I can do from there, let me orbit just a little bit, is I can examine how my axes are facing and determine if it's incorrect. And looking at it now, I see that Z is incorrect and Y is incorrect. So for me, Z would be pointing up and Y would be pointing forward. X is fine, it would be pointing to the right. So what I'm going to do to fix this is I'm just going to click Setup WCS and I'm going to select the Z and X plane. So we'll select Z first, and there we go, that actually fixed it. So now our Z is pointing up, our X is pointing to the right, and Y is pointing forward. So now our axes are in the proper orientation. So what we want to do now is go to our selection here and then go ahead and select our bore. So there we go. The next thing we'll do is go into our heights tab. And now we haven't faced off this part of our material yet. So instead of hole top, what I'm actually going to do is go to stock top, because again, there is some material up here. And then we'll go to the whole bottom. So that should be fine. We'll leave everything else stock. Sorry, we'll leave everything else default. And then we'll go ahead and click OK. And then again, we're going to right click and simulate and just make sure that we aren't doing anything dumb. So there we go. We bore in, we go all the way down. No issues at all. Okay, so I'm going to exit that. And so if I toggle between the two toolpaths here, you'll notice again that Fusion doesn't actually rotate our fixture and our material like we would see on our machine when our 4th axis moves. Instead, Fusion 360 just changes the way the spindle is facing, or the tool and the tool holder. So on our machines, our 4th axis would actually rotate, but Fusion doesn't show that. So just keep that in mind so you don't get confused. We'll go back to our home view here again, just so I can toggle back and forth. You can see it a little better. And the reason why I didn't go ahead and do a 2D adaptive and clear out this circular pocket here and finish the sidewalls is because I tried that on the first time I made the pump top, and actually when I did the bore after I already cleared out the circle, I ended up leaving some ugly burrs around the edges here. So when I did the boring operation first and then came in and cleared out the pocket and did a nice 2D contour to sort of make a nice surface finish there, that left me with no burrs and a nice finish. So that's the reason why we're going to do the bore before I go ahead and do the adaptive clearing. So what we'll do now is we'll go ahead and we'll do one more toolpath, and then that will be it for this tutorial. So let's go back to our home view and let's go ahead and go to our next toolpath. So what we're going to do is we're going to finish off today's tutorial with a 2D adaptive clearing where we remove most of the material from the center pocket here. Before I do that, I did want to explain why I decided to use a bore rather than a pocketing operation. So if I right click and I simulate, you notice here the boring operation is just one smooth circular motion downward, whereas a pocketing operation, there would be a step down. So I feel the boring operation with just that smooth circular motion downward is just a little better. So that is why I chose it. So what we'll go ahead now, so we'll go back to home view and we'll finish off the tutorial. We're going to go to 2D adaptive clearing. So I'm going to go ahead and click it here. Again, I'm going to select tool 8. You can see the pattern here again since I don't have a tool changer. I'm trying to be as efficient as I can be. So let's go ahead and select tool 8. And what I'm going to do now is I'm just going to up our cutting feed rate to 40 inches per minute. That leaves us with about 1.7 thousandths per tooth. We'll go into geometry and I want to go ahead and select the bottom of our circle here. So that's fine. We do not want stock top since we already faced the top of our part on this side. What I'm going to do is go ahead and select model top. Perfect. Then we're going to go into heights again. I'm going to use an optimal load of 30 thousandths. Usually use somewhere around 10% the diameter of the tool. So I find 30 thousandths works well for me. So everything there looks fine. We're leaving 20 thousandths on the sidewalls and on the floor. And we'll come and we'll clean that up with a 2D contour in the next tutorial. All right, so that all looks good. What I will do is I'll go ahead and change this ramp clearance heights to 20 thousandths instead of 100 thousandths, just so that we don't start machining above the part and really we just cut air and waste time. If we go to just about 20 thousandths above, that will save us or prevent us from cutting air. So that's what we're going to do. Okay, we'll just sort of step back through this, make sure everything is okay. Yep, and the one thing I'll mention here is you notice we didn't need to go to tool orientation again because again, this is the way we initialize our setup and our axes are pointed in the right direction. So it's automatically going to rotate the fourth axis for us. So I'm going to go ahead and select OK. And then we will go ahead and simulate our toolpath. So right click, simulate. All right, I just like using the timeline here. Makes it a little easier. So we're performing helical entry and then we're just gonna clear away all the material, just leaving 20 thousandths on the sidewalls and on the floor, which again we'll clean up in the next tutorial with a 2D contour toolpath. So everything looks fine there. And so now what I'll do is I'm just going to go ahead and step through these toolpaths so you can see how Fusion 360 sort of changes the orientation of the spindle. And really what would happen on your Tormach is your fourth axis would rotate. Okay, so everything there looks good. And again, just to emphasize here on our third toolpath, our 2D adaptive, we didn't need to use the tool orientation on that toolpath or on our facing toolpath because again, this is the default orientation where we did our setup. So that should do it, and I hope you enjoy this, and I'll see you in the next tutorial. Alright, so here we come in, perform our first facing operation. Again, we're using that Gorilla Silverback end mill, 3 flutes, 3/8 inch shank. We're going 40 inches per minute, 40 thousandths depth of cut, and 50% diameter of the tool for width of cut. Again, we're going nice and slow here, just trying to get a good surface finish, not going as fast as I would on a traditional vise, again, because as you can see, the stock is sort of a giant lever. Alright, so now we are getting ready to transition into our boring operation. You'll see the face finish, and then the spindle lifts, the 4th axis turns, and we jump right into that nice smooth boring operation, just making the hole so later we can come back in here and tap this G1/4 so that our coolant fittings will fit into our pump top. Alright, so now we finish up the boring operation and we transition into our 2D adaptive clearing using the same Gorilla end mill. You'll notice that again the stock is a cantilever, so you'll hear some resonance and some chatter as we are performing this helical entry into the part. Again, we're going 40 inches per minute with a 300 thousandths depth of cut and a 30 thousandths optimal load or width of cut. Right, and so now we're really moving, getting those chips flying, and again you can hear using the 4th axis is not as solid as using a traditional vise. So again, it's a cantilever, so we have to keep that in mind when we are tuning our speeds and feeds.